All right, welcome to Pomodoro Joe for Wednesday, October 4th, 2023. Today we're looking at LeetCode problem 706, Design Hash Map. This is an easy problem. So our goal is to design a hash map without using any built-in hash table libraries. So that means no dictionaries, no default dictionaries, no sets. Those are all hash table libraries. So what can we use? Well, we need something to store our variables. So we can use things like lists or arrays. That's kind of the extent of my knowledge. I mean, we could use decks and things like that, but essentially a list is going to be our storage here. Implement the myHashMap class. So we have a constructor. This initializes the object with an empty map. Then let's see, we have a put, and that will take a key value pair and it will put the key value pair into the map. So the key will map to the value. All right. Then we have a get that just takes the key. So we'll do a lookup using the key and we'll return the value. And let's see, it says we return -1 if the map contains no mapping for this key. All right. And then we have remove. And we just pass in the key and we'll remove the corresponding value. Cool. All right, so this is a fun one. I like these kinds of problems. Let's put 25 minutes on the Pomodoro timer and we'll get started. Okay, so a hash map is a key value pair. Essentially, you're given a key and it maps to a value. Anytime you're asked to return the value with the key, you have to do a lookup. So we need some type of storage. Now we can't use dictionaries because those are the built-in library hash maps. We can't use default dictionaries. We can't use sets. It doesn't leave us a lot of options. So I think for our storage, we're just going to use a list or an array here. So I'm going to call it storage. Now, because this is a class, in our init, we actually have to use the self object. So we have self.storage. And let's see, we'll make this equal to an array. And now we want to allocate all of our memory right up front. How big do we need to make this thing? Let's take a look here. We have some constraints. So our key and our value, and they're both between 0 and 10 to the 6th. All right, so let's make this thing 10 to the 6th units long. So that's 10, 2, 3, 4, 5, 6. And it looks like our value could be up to 10 to the 6th. So we actually need to add one more because this is a 0-based array. And let's see, we do need to fill this with something. Initially, I was thinking we'd just put none in here, but since it tells us right here, if we don't have a value, we'll return -1. So we'll actually initialize this with -1. Cool. So now we have our storage. We just have one big array that's filled with -1s, and it's of 10 to the 6th plus 1 in size. Okay, now when we get a put, the put has a key and a value. Now we know our key is actually within the same range of 0 to 10 to the 6th, so we can use that as our index into our storage. So our storage here, actually, again, we have to use self.storage. For this key, this index, we'll just set it equal to the value. Now we've stored the value. Cool. Now if we ever need to get this back out, we can just return self.storage for this key. And then if we want to remove it, then we do a self.storage for this key, and we'll set it equal to -1 to sort of reset it. And that should do it. I think we're done. Cool, let's run this and see how we do. Okay, seems to work. Let's see if we can pass all the tests. And we pass. Sweet. We don't do great. We only beat 30% for runtime, only, what, 9% for memory? Yeah, not great. Now, I have a suspicion that some of the solutions might not be following the rules. So let's take a quick look here. And I was right. So the top solution uses a dictionary, which is not allowed. According to the rules, it says you're not allowed to use any built-in hash maps. So this one, even though it's a fast solution, of course it's going to be fast because it's using the built-in dictionary, which is essentially what a hash map is. All right, so that doesn't really help us. Okay, so here's a faster solution that is legit. Now this is interesting. So what they're doing here is they're creating buckets. So you can see they have an array of arrays. So what they're doing is they're creating sort of a set of buckets. And if you need to access a bucket, you have to generate a new key, or essentially two keys or two indices out of your initial key. Okay, imagine this. Imagine you have, instead of 0 to 10 to the 6th, it's from 0 to 100. Now you can create one array that's 0 to 100 in length, 101 elements, or you could create an array that's only 10 elements long, but each one of those elements is another list, another array of 10 elements. So you could create one long list, or you can create an array of arrays. So you'll have these buckets, 10 buckets, each of length 10. So to figure out which bucket you're in, you'll basically have to do a divide of your key. So let's say you're trying to get to 32. You have, your key is 32. Well, you need to figure out which bucket that is. So if you're starting at 0 and each bucket is 10, so you'll have bucket at index 0, and that basically will contain 10 elements going from 0 through 9. Then you have your bucket at index 1, that's another 10 elements, but that's going to go from 10 to 19. Then you have a bucket at index 2, and that's going to go from 20 to 29, and then bucket at index 3, which will go from 30 to 39. So you say, okay, I need to go to bucket at index 3, and then within bucket at index 3, I have 10 elements to choose from. I need to choose the third element, that's 0, 1, 2. So that's going to give us the element at 32. Bucket 3, element 2, or element 3, because it's 0 indexed. Anyway, so that's another way we could do this. This is a little bit smarter, a little bit more compact. It looks like it's a little bit faster, but it is a little bit more complicated. So I just went with the easy route. I think that's a good way to start. Let's see if anyone else is doing anything. Yeah, they're doing something similar. Anyway, I'm pretty satisfied with our solution. It's simple, it's straightforward, it gets the job done. It's not super fast, but if you really want to improve on this, what you could do is have this array of buckets instead. Try that one on your own. Yeah, that's a good one to try out. All right, I think that's it for me. I hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.